And we will wait for the last few minutes so that the audience can arrive. Thank you everybody for attending the webinar today. I will share a brief introduction video to get into the mood and then hand it over to our moderator for today. So please enjoy the little intro video. Yes, thank you for watching this. This was our introduction video because soon we will have the World Engineering Day and our partner WFEO is one of the initiators of this day with the UN. So especially in light of this, we are very happy that you are supporting the engineers in this regard and also to the topic. So with our official introduction, I then hand over to Janice, our moderator.
Everyone, and welcome to this webinar, Water Reuse for a Sustainable Industry. I am Janice Malia, and I will be the moderator for this webinar, which is being organized jointly by the Young Engineers Future Leaders Committee within the World Federation of Engineering Organizations and the Public Policy Department within the European Young Engineers Association. Just to give you a little problem background, in the EU and UK, 52 million people and 995 billion euro in economic activity are exposed to water scarcity. Managing to pursue the efforts to remain within the 1.5 degrees Celsius global warming level would mean the number of people and economic activity subject to water scarcity could still rise by 14% and 13% respectively. It is therefore the aim of this webinar to define the existing barriers between politics, industry, and academia to promote more water reuse and create a sound cohesion between the natural and technical world. In the chat box, we have posted a survey we are conducting to gather information about young engineering professionals' perception on water reuse. So please feel free to fill it in. Also, we are experiencing some issues with the YouTube live chat, and unfortunately, people who are on the Zoom platform only will be able to submit their questions. When posting your questions, please make sure to first write the name of the speaker that you intend to address the question to, followed by the question. I would like to take this opportunity to thank our esteemed guests for being here with us today. Mr. Virginijus Sinkevicius, European Commissioner for the Environment, Oceans and Fisheries, Ms. Valentina Bastino, Policy Officer for Clean Water within the DG for Environment, and will be joining the panel discussion as a representative of the European Commission. Ms. Francesca Pizza, Secretary for the Joint Working Group on Water Use for Euro, Professor Alexandros Stefanakis, Editor-in-Chief of the General Circular Economy and Sustainability, Professor Joaquim Pucas Martin, former Secretary of State for the Environment of Portugal, and Mr. Hans Martin Friemuller, Chief Executive Officer of the Kellenberg Utility and Chairman of Danish Water Forum. Therefore, with no further ado, we shall kick off this webinar with some opening remarks from the representatives of the organizing committees. I would like to introduce Firas Boudiab, Chair of the WFEO YEFL Committee. Over to you, Firas.
Hello, and welcome to today's webinar, which is on water reuse for a sustainable industry. I'm Firas Boudiab. I'm the chair of the Young Engineers Future Leaders Committee in the World Federation of Engineering Organization. I guess many of you know that this organization has been founded in 1968 under the auspices of UNESCO. Really, WFEO brings several national organizations from around 100 nations and represents more than 30 million engineers. We, as the Young Engineers Future Leader Committees, we're trying to give a global voice for young engineers, and we try to allow for input from we can say that from a previously unrepresented segment of the engineering population, knowing that the young engineers that nowadays are the drivers for innovation, creativity, and technology development. We're trying in the Young Engineers Future Leaders Committee to connect with the external organizations to make sure that the young engineer voice are prominently featured in all discussions in relation to sustainable development goals. I would like to take this opportunity today to speak a bit about the 4th of March, which is UNESCO International Day. It's an annual celebration every 4th of March that highlight the achievements of engineers and engineering in our modern world. For this year, for 2021, and in celebration for WED 2021, the WFEO, in particular, the Young Engineers and Future Leaders Committee and the Engineering and Innovative Technology Committee, trying to organize an event which is by asking young engineers all around the world to submit a video showing contributions young engineers are making towards a more sustainable, resilient, and inclusive world. We'll promote these videos, we'll collect these videos, and then all the young engineers with, let's say, with the best videos that answers the typical or the top 3 questions of this event will be compiled and presented in the WED celebrations on March 4. Lastly, I would like to extend my thanks for the speakers of today and to the teams of YEFL and EYE who contributed a lot for the preparation of this webinar. I thank you everyone for joining us, and I thank you for taking time to view our webinar. Have a great day ahead, and we're all ready to go for the listen to the speakers today. Thank you, Dennis. Yeah.
So next, I would like to introduce Nadia Yang, Public Policy Vice President for EYE.
Yes, thanks a lot, Janice. So it is my pleasure to introduce our organization. We're called the European Young Engineers, which is the largest NGO of its kind and represents more than 350,000 young engineers across Europe. Since 1994, it has been organizing biannual conferences to foster the relationship between our members. Its vision now is to be the voice of young engineers in Europe, as it becomes more perceivable that in many public debates nowadays, the views of young engineers have been barely represented. However, we believe more technical knowledge will be highly beneficial for political decision-making, and especially because many solutions are of technological nature and should be considered with the technical expertise at hand, we think we can be a big contribution in this regard. Therefore, we launched the initiative Network of European Engineers in Politics, with which we bring together politicians with engineering affiliations. But we have a lot of other initiatives as well, such as the online series Horizon to create a platform of exchange where young engineers can share their views to leaders in society and vice versa. In parallel, our working groups work on policy papers and workshops on various topics, such as hydrogen, mobility, future of work, and water reuse in a circular economy. Especially regarding the latter, I'm very keen on learning from the insights of today's keynote speakers, sharing the views of our audience with them, and making young engineers and young people more aware of the importance of today's topic. So I can just join Firas in saying, thanks a lot for this wonderful partnership, and thanks a lot for joining us today.
Thank you, Nadia. I now ask our guests to briefly introduce themselves. Commissioner, Mr. Sinkevicius.
Hello, and good afternoon to everybody, of course, and thank you very much for this invitation. It's always a pleasure to talk to people who deliver our policies on the ground. I'm the European Commissioner for Environment, Oceans and Fisheries. Now, as I understand, you will later ask me to deliver my speech. You would like me to only introduce myself. So I will probably stop here.
Good afternoon. I'm Francesca Pizza. I am representing you today, my association, that is EURO. This is the European Federation of National Association, Water Association, representing both the public and private water sector. And I'm working at the Joint Working Group on Water Reuse since 2015. I'm very pleased to be here today.
Professor Poucas Martins.
Hello, I'm Joaquim Poucas Martins. I'm an engineer from Portugal. I teach at Porto University. I've been in government in Portugal, Secretary of State for Environment a few years ago, and I've led a number of large water utilities and I'm now a consultant, water consultant in a number of countries in the world, namely Brazil, Mozambique, Angola, and so on.
Professor Stefanakis.
Hello, everyone. Thanks again for the invitation. I'm a graduate environmental engineer from Greece, and currently I'm assistant professor at the Technical University of Crete here in Greece since last year, and editor-in-chief, as you mentioned, of a journal on circular economy. Before I come back to Greece, I worked in the industry on the water and wastewater sector. So I have a lot of experience, good and bad experience from all over the world dealing and managing wastewater, trying to manage it in a sustainable way. So I'm very happy that your topic today combines water reuse in the industry in a circular economy context. And I hope that similar discussions will pop up in the future more and more often. So thanks again.
Thank you. And finally, Mr. Müller.
Thank you. And my name is Hans Martin Müller, and I'm from Denmark, from Kalundborg Utility, which is a multi-utility with water supply, energy, wastewater treatment, and so on and so on. Before I joined the utility, I've been working as a consultant for water and energy and made projects all over the world, more or less. Especially for the last 7 years, I've been working very intense with reuse of water, and I hope I can present you for some of the things that we have made a little bit later. Thank you.
Thank you all for your introductions. So we shall now dive into the first part of the webinar, where we shall speak about the circular economy and where its future lies with the newly enacted Circular Economy Action Plan. Commissioner, the floor is once again yours.
Thank you very much. Once again, good afternoon to everybody and everyone, and of course, thank you very much for this webinar, because I think this webinar is timely, because we need young people and engineers in particular to start working on new green solutions, and these solutions don't come from the European quarter in Brussels, although you will find engineers here as well. The innovative ideas come above all from creative and resourceful people like you from all over Europe and the world, and people who understand the need to think green. What I would like to do is start with the background and explain how we arrived at these policies, and then look at them in a little more detail, the implications they have for people tasked with their implementation. The European Green Deal, our new growth strategy, aims at achieving a climate neutral and circular economy by 2050. And that means that the important decisions need to be taken now. It implies the full mobilization of industry and business, but it is not an obligation so much as an opportunity. It is a chance to innovate and invest more sustainably, not just in general, but in very specific fields like water reuse. The reasons are very clear. Half of all greenhouse gas emissions and more than 90% of water stress and biodiversity loss come from resource extraction and processing. And water scarcity is getting worse in some parts of the EU. And climate change will exacerbate the problem. Droughts will be more frequent, more severe, and longer lasting. Water is increasingly a precious commodity. That means significant costs. Droughts can have a cascading effect on infrastructure, forestry, and biodiversity. Here in Europe, the losses to agriculture, the energy sector, and the public water supply are already €9 billion worth every year. So climate change affects not just the economy, but the health and well-being of citizens as well. And the impacts affect vulnerable groups even more, which makes existing inequalities even worse. The European Green Deal is there to address these challenges to our planet and quality of life. And even in the current crisis, we should not lose focus. We have to address the long-term risks up front. We have launched a number of initiatives to improve the design of our future, from the Circular Economy Action Plan, the biodiversity and the frame and the farm to fork strategies, to the renovation wave and the new European Bauhaus. All these initiatives call for a comprehensive response to the challenges of the water, food, energy, resources nexus. Water is, of course, essential to the sustainability agenda. If we are to preserve our resources, we need a more ambitious policy framework to promote efficient use of water, notably water reuse. And I'm sure you are familiar with the regulation on minimum requirements for water reuse for agricultural irrigation adopted in June last year. It's a very powerful instrument because it makes water reuse a political priority for the first time. If we take a quick look at the main features, we see that it's built around harmonized minimum water quality requirements for the safe reuse of treated urban wastewaters in agricultural irrigation. It also harmonizes minimum monitoring requirements, like the frequency of monitoring for each quality parameter. There are risk management provisions to address potential health and possible environmental risks, permitting requirements, and of course, provisions on transparency so that key information is made available to the public. The overall intention is to ensure a high level of ambition for water reuse in member states that already apply the practice. This also has the advantage of reassuring member states that have been less affected by water scarcity and drought so far, but are starting to feel the effects of climate change. It gives them a framework they can trust in the future. In fact, it's a good advert for the circular economy all around. It shows in a very practical way how the economy and the environment can work together in a win-win situation for both. It's the kind of model that we would like to see spreading to the other sectors. Our goal is to facilitate reuse and efficiency across the board, including in industrial processes. So the coming integrated nutrient management plan, for example, as well as encouraging a more sustainable application of nutrients, also aims to stimulate the market for recovered nutrients. In the spirit of the circular economy, we want to encourage more systems thinking and more industrial symbiosis, where the waste from one process might be used in another. This applies not only to flows of materials and energy, but to water use and reuse as well. It's an area where we are studying very carefully at the moment in an ongoing review of the legal framework for industrial emissions. The public consultation on this is still open and runs until the end of March. So, of course, I would invite you all to take part in the process. Your input would be very valuable. The Commission has been supporting industrial water reuse for quite some time now. We are always there to support the uptake of green technologies. And that's why we developed a system to build trust in reliable technologies. If you aren't familiar with this, the EU Environment Technology Verification Scheme is now an EU certification mark. It's there to help solve a problem often faced by SMEs. You design a new technology, you know that it performs well above normal standards, or that it presents an innovative approach to a known environmental problem, but you can't break into the market. So environmental technology verification is there to provide independent, credible evidence of the advantages of your product. And the information is publicly available, and you can use it to compare your product with those of other manufacturers, convincing potential clients about the merits of your work. I think I'll stop here. I hope I've shown you big priority in water reuse for the European sustainability agenda. Efficient use of water is already important enough, but that importance is sure to grow, and as the consequences of climate change spread more widely across the Union. When you build infrastructure, you are looking to the longer term by definition, and there has certainly never been a better time for these technologies, and the business opportunities will continue to grow. So over to you. We need your ingenuity and your ideas, because you are the ones who translate these ambitions into tangible practices on the ground. The future and how far we can go will be determined by your skills, ambition, and imagination. And I'm sure that you, just like me, feel this is both a great responsibility, but also an exciting challenge. So I'm very keen to hear your thoughts about how that happened. Thank you very much for your attention.
Thank you very much, Commissioner, for your words. So now I would like to turn to our other panelists, and I would like to ask whether you have any remarks that you would like to add, or even any questions that you would like the Commissioner to briefly reply to in a couple of minutes. Perhaps Professor Pukas-Martin, you can go first.
Thank you very much. Thanks again for the invitation to this great event. I would like to remind, and I certainly have in mind, that most of our participants will be working in the year 2070. So how will the world be in 2070? Will there be water wars before that? Will there be enough water for 10 or 12 billion people that we might have? This is the sort of questions that are behind the major topic of this event. We talk about reuse, circular economy, but in water, we are terribly far from circular economy. We basically don't reuse water formally. We do that indirectly, and it is true that any drop of water that eventually reaches the sea, say in Europe, that drop may pass in perhaps 7 or 8 houses before it gets there. So it means that we in fact reuse water, but we do not reuse water formally. We do indirect reuse. I have a couple of slides that I would like to be passed as I talk. The first one, please. Do we have the slide there?
Would you like to present them now or later on?
No.
Nadia, can you share the screen, please?
So basically, we reuse very little water. Only Israel, they do it a lot, Spain, but formally, we don't reuse that much, which means that we still have lots of opportunities, because for us to have water for all the uses in the future, we cannot rely only on the known and proved solutions. We have to come to new solutions, and those new solutions are basically reuse and desalination. Of course, we have to manage water very carefully, but that's not enough. If we didn't have reuse, if we didn't have desalination, the answer to those questions, will there be water wars, will there be enough water in a context of climate change, won't be as optimistic. And in the end, I'm optimistic about the future, because basically we'll be wise. There are engineering solutions for reuse indefinitely water, that is, use spaceships. It's too expensive just to deliver a bottle of water or buckets of water to a spaceship. So they use water again and again and again. And we only don't only reuse as much as we do, because people think that water is too cheap for farmers, too cheap for industrialists. And the result is that we add pollution to the rivers, and then you have to deal with that pollution. Next slide, please. We use the same water for different purposes, and we all know that doesn't always make sense. Next, please. This is perhaps the most important message I would like to pass. We basically, in cities, in industries, we abstract water from rivers, we use it and we discharge it, partially treated. Doing that, we give nature the job of doing what we should be doing. We don't treat water enough. We expect nature to do it, but as we are doing that, we add pollution and we live in a more polluted world than we would like. What if we did differently? Why don't we do as they do it in spaceships? Or, as I mentioned later on, as they do it in Namibia for 50 years? Why don't you actually reuse the water? If you did, we would solve two problems. There wouldn't be water scarcity due to climate change, and we'll have it, that's for sure. And on the other hand, we wouldn't have river pollution. In Europe, we are front runners in terms of water quality. Our framework water directive was pioneer in the world in terms of protecting the water quality, even if it is not to be used by humans. So if we stop pollution, and we could, if we recycle more, we would live in a world without river pollution. And I think young people deserve to have that hope. Next slide, please. So basically, we have already the technology to actually direct reuse water. We can link an existing wastewater treatment plant to a water treatment plant, or actually make just one. And we can do it at the house level or at quarter or building level. Next slide, please. Bill Gates wanted to be shown drinking water that has been wasted a few minutes before. That's very important, because although we know that we can do that, we need stars to actually convince people that this is the right thing to do. I did it in Namibia, I did it in Singapore. If people like pop stars or like Cristiano Ronaldo or Madonna, if they were shown drinking water, reused water, that would make a hell of a difference. Please, next slide. I was surprised, some of you will be surprised, that they are doing that in Namibia for 50 years. I've been there just a few months ago, and yes, we can drink water that has been sewage before. There's no problem. It's more secure to do that than actually drinking water that in fact has been partially sewage before, because we are actually recycling, reusing partially treated water. Next, please. In Singapore, it's the world's largest scale project of using what they call new water. They use, but there the point, the interesting point is that the water that is so pure that they actually sell it to the semiconductor industry that needs water a little bit more like distilled water. So yes, it's possible. Yes, it's being done at large scale. Next, please. And it's not prohibitive anymore. We can have water, we can transform sewage and or seawater into potable water for less than 50 cents a cubic meter. One family uses, say, 10 cubic meters a month. That family, if that family has $5 extra or euros, that family will can be served with reused or seawater, distilled seawater, or desalinated water. Okay. So we are in a world in which houses, we are going towards sustainable houses, some not connected to the grid, electrical grid. We can do the same in terms of water. We can obtain water from the air, because there is much more water in the air than there is in rivers. Animals in deserts, they know, and they do it, they live out of it. So my message is a message of hope, a message that if we are wise, we'll have enough water, we will live in a world with less pollution. Of course, technology is part of it. Water is a political issue. Great decisions regarding water are political. They should be based on sound technical and engineering evidence. And yes, we engineers have solutions for water in the future. And I'll stop now.
Thank you, Professor Pukas-Martin. Perhaps Mr. Mueller can go next. You can give us our remarks and also your insights on the Kallenberg utility.
You are muted.
Can you hear me now? Okay, very good. Thank you. I will start to give the comment to the commissioner, because I quite agree that the strong legislation is necessary for things to happen quite fast. So what we're going to look into is, of course, legislation and innovation. That should go hand in hand and give us, well, as you said, Professor Joachim, some hope. But back to Kalundborg Utility. It's a utility working with drinking water. We provide our customers with three qualities of drinking water, and handling the wastewater, district heating, and so on, so on. So if you can take the next slide, please. We have established a unique partnership between the industries and the utility in Kalundborg. And we have based it on one very, very key principle, and that is that one residual from one company becomes a resource in another company. And I will just describe what you can see on this slide. You see the lake. The utility abstract water from the lake, are letting it to the oil refinery, where they use it as cooling water. The water will be heated because it's used as cooling water. It is then led to the energy producer, who produce electricity and steam and district heating, and they warm the same water a little bit more. It is used in the district heating system, and they heat it a little bit more, and it is used as steam for the industrial production. In the industries where they use it for different purposes, the steam, it will be returned into water, and we will gain it back to the wastewater treatment plant. But before we do that, the wastewater is very, very high of organic content. So the industry take out the organic content, use it for production of biogas and electricity, and we are getting it to the treatment plant, where the water is still about 30 to 35 degrees hot. We are using it to boost our processes, and then after we have done that, we can treat much more water because we boost it with hot water, and then we mix it with the other wastewater, and it's still about 30 degrees. We use it in a heat pump, take out the heat for third time, and then are using the heat in our district heating system. And then after that, we will dispose the water. It is also the fact that every industry is connected with their own pipe system to the utility. So on the utility, we decide, can we reuse the water for other purposes, or should we just mix it and treat it as a normal wastewater? So in fact, we have made a circular system where we produce heat for our district heating by hot wastewater. We circulate the water for 3 or 4 times, reuse the same drop 3 or 4 times. And this is, we have been doing that for about, a lot of years. And there's a lot of financial benefits. And there's also, of course, the environmental benefits, the CSR goals, less emission of CO2. Having this system working, we are saving about 650,000 tons CO2 per year. And if you put on the next slide, you can see we have about 22 different streams running in the city between industries, utilities, and other instances in the area. So and we call this system the Kalundborg symbiosis, and it has been working very, very good. The company is saving about $28 million per year having this cooperation instead of buying new materials or new water or energy. So what we say in Kalundborg is also to take a vague message is that technology makes it possible, but people make it happen. Thank you.
Thank you, Mr. Müller. So I think Professor Stefanakis can go next with your remarks about circular economy.
Yes, I think most of the most crucial issues have already mentioned by the previous speakers. As I said in the beginning, I was particularly happy for this invitation because I see the word water reuse next to circular economy. Why is that? Because until a few years ago, if I would talk about water reuse as part of the circular economy context, many people will disagree because there was the perception that no, circular economy has mostly to do with organic waste, recycling, or materials. But I think this is now established that water reuse, especially in the industry, is a significant part of a circular economy action plan, as it is this new one introduced by the EU. So, especially in Europe, we have many challenges. Most of us now live in cities. We have to deal with aging infrastructure. So there will be massive investment that is required also in the future. So we need to take all this into consideration. And as mentioned already, technically, as you will be young engineers or already are, you have a toolbox already available that you can use to produce the technical solutions required to allow for the safe reuse in the industry or in the agriculture. But as an engineer, I think in the already, it's not only this enough. Professor Poca-Martins mentioned already that it's also have to do with the social acceptance. I've been in many cases where we had the treated effluent, safe, it met all the criteria, but still people were hesitant to reuse it for irrigation. So what we did, we just recharged the groundwater, and 15, 20 kilometers downstream, the farmers will just pump it out. So this is something that you also will face, and you will have also to convince and communicate also to the people that this is something that can be done in a safe way, and it is for the benefit of them. Also, we need to have really good examples. I'm working all these years using nature-based solutions. For example, in the Middle East, we had a large project where we treated the oily wastewater from the oil and gas production and exploration using a nature-based solution, a treatment wetland. But what we did then, we had a huge water in the desert. So we say we should reuse it, but we should not reuse it just to make it that desert look green. So we irrigated biofuels, so generally crops that have a market value. And by the biofuels that was produced, we already had the first flight of Etihad Airways from Abu Dhabi to Amsterdam, where 50% of the fuel was produced through biofuels. So you see also the further opportunities, not just technically that need further optimization, but also for future investments in different fields, which will arise from the technical efficiency and optimization of reusing treated waters, treated wastewater in the industry or in agriculture. So there are a lot of challenges, but also a lot of opportunities for you as young engineers. And my message for you will be just, you should be not just creative and innovative, as we usually say, you should be also flexible enough to be able to monitor the changes in the world, which happens nowadays probably on a daily basis, so that you can adapt also to their needs that are today and will come in the near future.
Thank you, Professor Stefanakis. And lastly, Ms. Spitzer, can you give us your remarks and your opinion on circular economy?
Yeah, I fully agree with Professor Poukas Martin, with Professor Stefanakis, because as Euro, but also as simply water operators, we have fully supported the European regulation on water reuse, even if this regulation in the end focuses only on direct agricultural irrigation, while we can have many other reuses possible. For example, landscaping irrigation or irrigation of public gardens, street washing, and so on. We can really think about water as something that can be recycled in many ways. And many of our members have a lot of case studies on this. I work, for example, in one of the largest case study of Europe, where that is in the city of Milano. Our wastewater treatment plant is treating every year 150 million of cubic meters of wastewater that are totally recycled and destined to agricultural irrigation and to the irrigation of a public area that is a wet area. As Professor Stefanakis said, the public participation is a very important point, because we need to demonstrate to the public that water reuse is a safe practice, is a real and modern practice, and we need to support people to to overlap the psychological barriers about wastewater recycling. This is very important. What we saw here in Milano is that having a strict contact with the citizens, with public, with schools, with educational projects is the very important key to avoid psychological barriers in water reuse. This is the first thing. And the second remark is that after this regulation, European Commission should necessarily support a strategy to promote and incentivize water reuse in place of the simple extraction of fresh water from available natural resources, because otherwise there will be always a situation, as Professor Poukas Martin said, of non-controlled reuse. The agricultural farmers will just take water from the first source available. And the message we want to bring with us is that we want to do a real reuse, a real recycle of water, a real circular economy. So this is the role of the Commission in incentivizing this practice is fundamental from our point of view.
Thank you, Ms. Spitzer. I think we have Ms. Bastino joining us now. With those remarks, we have come to the end of the first part of the webinar, but I think Ms. Bastino, representing the European Commission, would you like to close this first part of the webinar with some of your remarks in response to the other panelists' views on circular economy?
Good afternoon. I hope I managed to unmute myself, or that I have been unmuted. Yes, thank you for inviting me to join this seminar, and thank you to all the speakers for the interesting interventions. You're kind of preaching to the converted here. I have been working for the past few years in the unit in the European Commission that deals with clean water, but more specifically, I've been working on the preparation of the water reuse regulation. So I can only agree with all the elements that the previous speakers have put on the table. And notably, I can only confirm how I also saw that public perception is often one of the first obstacles that you would encounter when you try to set up a water reuse scheme. In our negotiations with the member states, this issue came up repeatedly. I was particularly impressed by the presentation on the Danish utility. You will forgive me, Kalundborg, I might mispronounce it. As Francesca Pizza has highlighted just a minute ago, the water reuse regulation that has come into force in June last year indeed focuses for the moment exclusively on agricultural irrigation. The reason behind this choice of focusing on agricultural irrigation was because it is, at least in Europe, if not in the world, one of the largest uses of water. And because of the internal market implications that a regulation would have, the Commission made the choice of focusing on this use as a start. However, I would like to highlight the fact that the regulation itself is committing the European Commission into looking into broader uses for water reuse. One of these being the environmental uses, such as irrigations of public spaces, green areas, etc. But also industrial reuse is in particular one aspect of the work of the Commission in the future few years, as announced, by the way, in the Circular Economy Action Plan. So I'm very curious to hear further from the representatives of the engineering professions and the representatives from water utilities as to how could the policy work that the Commission does or can do, how we could support this expansion of water use in the industrial sector, for example. And in particular, in the agricultural irrigation sphere, we have set minimum requirements to protect health, as well as risk management requirements for also environmental aspects and environmental impacts that this reuse can have in irrigation. Now, my question as a non-engineer, by the way, is what sort of policies would the industry need to take up water reuse and make it part of their normal operations? Would it make sense to have a certain standard set per sector, or would each sector have such specific requirements that it would make little sense to have a sort of homogeneous instrument at EU level? So with this, I think I am at the stage where I will throw the ball right back into your court, as I'm very keen to learn from your experiences and see how this can feed into our future work. Thank you very much.
Thank you, Ms. Bastino. Perhaps Professor Stefanakis would like to reply to her question, or Professor Paukas-Martin?
Yeah, just a few words. It is absolutely right that the question what we can do on the legislation, European level, to promote reuse in the industry. The challenges here are much higher because when we talk about industrial wastewater, of course, we don't talk about more or less similar quality of the water that is to be treated so that it can be reused. So industrial wastewater can be from many different sources, different qualities, can be much more difficult to treat, to reach whatever standards we want to reach for reuse. So I don't think so we can have like a standardized quality limits for the reuse. It should be done probably per sector, depending on the quality, the types of the pollutants, the nature of the pollutants that exist in each wastewater effluent. But it's not just this, it also has to do with the technologies that can be used to treat such water, about their effectiveness. Then it should be given some extra motives to industries. Of course, there is a benefit of reusing or recycling treated effluents back to the industrial processes, and sometimes you don't need to reach very strict standards. So each industrial sector can perhaps identify what will be the minimum requirements if the water is to be reused in an industrial process. So it's a more complicated problem here to solve, but it's not something that cannot be done. It's something that should be done. And with extra motives to the industry, I think the industrial sector will also realize the benefits for them. I mean, I have several personal experience of industries that apply nature-based solutions. They treated their effluents and they are recycling back to the industrial process. So they saved also money, they saved resources, they reduced their carbon footprint by using also a green technology for the treatment itself, not just by recycling the treated effluent. They reduce the fresh water that the industry consumes on a daily basis. So it is a win-win situation, both from the financial aspect and from the environmental.
If I may add a comment. I think I was impressed with the excellent solution, Danish solution. I mean, the Nexus water, energy, and materials. And I think that's for sure, from my point of view, a way to go. The simplest approach, say, of recycling or using water, urban water for agriculture, I think it's, of course, it's interesting, but it doesn't solve many problems. Where there are people, there are no cabbages, and vice versa. I mean, you need an extensive infrastructure like they have it in Israel, for instance, to actually make sure the water from cities gets to agriculture fields. Otherwise, I mean, you would be reusing water for less noble things like washing streets or cars or whatever. It's better than nothing, but I think it's a very shy approach. That's just thinking of reusing water in agriculture. Also, we claim water is very scarce and pollution is a problem, but in the end, water is too cheap. Fresh water is too cheap for farmers and for industries, and if they have access to almost free water from nature, they will never put a cent on recycling or reusing. So we have to put a price on water, otherwise we won't value it enough. And in the end, I think in a few years, really, we have to think of a philosophically different approach to actually reusing water, which is closing the cycles, bringing circular economy truly to the water business, because it's still not there. And it's still not there, it's not because of technology, because technology is here, it's working, and it's affordable. It's because we don't think we can change fast. But that's not true. Look at these pandemics. We change in such a speed that we didn't think it would be possible before. This very organization of this event, I mean, people in different parts of the world using a platform in the meeting. And we learned how to live with that very soon. So if we really want to make sure that we won't have water wars, like Candice once said, whoever would solve the water problems would deserve 2 Nobel Prizes. But if we know that we are going to live in a water scarce world because of climate change, we know that we are more and more and more in the earth. The only solution for that is actually reusing water to an extent we haven't been using before. We are too shy. We are still spending a lot of effort to convince, for instance, farmers to use reused water. Have to move faster, I think.
Thank you, Professor Pocas-Martin. So this allows me to put forward another question, perhaps to Ms. Pizza, to give us your opinion on the barriers that current utilities may find to implement the symbiosis concept, and perhaps with regards to cost considerations, for instance, or any other aspects.
Yeah, I was thinking about this because, as Professor Pocas-Martin said, at the moment, currently, the fresh water is still too cheap to be replaced by recycled water. So we definitely need to start thinking about a cost for the freshwater extraction, groundwater extraction, and so on. And in addition to this, we have to say that those European countries where a regulation, a law for water use already exists, like Italy, Spain, and Greece, and so on, they have a very strict law that full of burdens, full of administrative burdens, chemical burdens, and so on. So it is not so easy to put in place a real water reuse scheme. On the contrary, it's very easy just to take the water from the environment, but this is not the correct point of view. So we really need to change this this mentality, this point of view, definitely. And this is the reason for which I say that the EU should promote a sort of incentivization of the practice. And for example, for industries, it's difficult to imagine a regulation for reuse in industries setting parameters, because every industry has its own processes, needs a specific water quality. So probably we need to push for politic instrument that would incentivize, let's say, good practice of recycling that will promote industries that don't use natural water and that are reducing the wastewater coming from their treatment. That this will mean that they are reusing the water in their cycle. We don't need the setting parameters for industrial reuse, but we need to set the policy option to incentivize this kind of circular reuse of the water into the industries. And this will reflect in a good way also for water operator, because this will reduce the trade effluent that are coming into the municipal wastewater treatment plant, affecting the final water quality, the sludge quality, and so on. We always have to think about an entire cycle. So this is the real circular mentality.
Thank you very much. So, Mr. Miller, what are your views on the points that have been made by Ms. Pizza? And do you think that there is still a lot of unused potential in terms of the possibility to implement more water symbiosis plants within Europe and perhaps even across the entire world?
Yes, I think it's looking into the geography and infrastructure, different places in the world. For instance, in Eastern, in Bangladesh, where they have industry parks, China, they have industry parks. All the industries are lying very close to each other, so it's possible to make them, to make symbiosis there. We have been working with breweries in different types of the different kinds of the world in order to make local symbiosis, but people are very they don't trust each other. So that means we have to put trust into that. You have to deal and accept that maybe if you have to share pie, sometimes you get a bigger part and sometimes the other get a bigger part. But looking into the cooperation in total, everybody wins with it. A commercial, it gives a surplus. And also regarding the value of water, I think we could all reflect that water is our most difficult or most rare resource, and it's the only resource that we didn't put on the stock market. So we can handle gold, we can handle everything, but we can't handle water in the stock market. And also looking into the reuse of water, what we did in Kalundborg was, of course, that we make the infrastructure ready for it. So every industry has its own pipe system to the treatment plant, and we are looking into, of course, and that's where we could start. It is that first we could look into a scheme where we use the right quality for the right purpose. There's no need to use pure drinking water to flush toilets and so on. So there's a lot of potential in our homes, houses, and so on. And also looking into Kalundborg, one of the industries is Novo Nordisk, and they produce more or less half of the world's insulin in Kalundborg based on water. And many of the industries we are discussing with, if we are coming with 2 glasses of water and say this is drinking water based on groundwater, this is drinking water based on wastewater, they would prefer the drinking water based on groundwater. There's simply you have to overwin yourself to drink, and it's the same quality, it's water quality, drinking water quality, but it's very, very difficult to get people drink wastewater, purified wastewater. So there's a lot of mental barriers that we have to deal with in order to get more reuse. And there's also the legislation, which Valentina said a little bit about, that the legislation, for instance, is that many places it's not allowed to use reused water in toilets, for instance, because there could be some splashes and there could be some infections of that. So there's a lot of stories that we have to deal with. Thank you.
Thank you for your comments, Mr. Miller. So perhaps now we can take our discussion more from a bit of a more technical view. Professor Stefanakis, perhaps can you comment a bit on the most promising technologies that are currently on the market, and what are the greatest issues that are met with the current technologies? So for instance, activated carbon is widely used. However, it still has a high carbon footprint. So what are your views on that?
Yeah, just one last comment on our previous discussion. We have some targets for each European country, for example, for the percentage of energy that should come from renewable energy sources. Why don't we do the same for the water reuse, for example? Of course, each country will start from the different, has a different start. Some countries, as Professor Pocas Martin showed, will start from a higher level. But this could help at least to have some clear targets where we want to be as European Union in 10, 15 years. And this will show also us where we should maybe focus our efforts and our resources. I'm talking always on the European level to reach whatever targets we want to set there for the water reuse in industry or agriculture. So I close this. Now regarding the technologies, the issue that has emerged the couple of decades is, I will say, the group of emerging pollutants. So some pollutants that we didn't know they exist some years back, few decades back. Now we have the analytical equipment to detect them. And we know that many of them have also some health impacts to ourselves, to the ecosystems. So it's not just anymore to treat wastewater to reach some standards for common pollutants. We have slowly also, the EU introduces some standards for some specific groups of emerging contaminants, some pharmaceuticals, personal care products. Still, there is a lot of work there to be done. So what we know so far is that most of the, let's say, conventional or the established technologies are not effective in removing these pollutants. So there is a lot of research already ongoing to identify how we can upgrade or improve such technologies or invent new technologies, particularly focusing on the effective removal of such emerging contaminants. So this is a topic that I think is already discussed and will be discussed more and more, especially when we are talking about water reusing in agriculture. Okay, because such pollutants could pass them to the food chain, and we still don't know what would be the possible effect on humans. So one is this. The other is that the treatment technology itself. There is a tendency nowadays that we look more into nature-based solutions. So nature-based technologies, technologies that themselves have, the process itself has a lower environmental impact, not just in terms of carbon footprint, but also the materials that are used. So we can use recycled material, no synthetic materials, and also have a minimum overall cost so that it can be easily implemented also in low-income regions. So, of course, you mentioned activated carbon. Okay, there are a lot of synthetic materials that and processes that maybe still we cannot avoid to bypass if, especially, we are talking about reaching high standards for water reuse. But this is a field which has there are a lot of opportunities for further development and optimization, both in terms of the established technologies, but also in the field of these new nature-based systems, where is already very good potential, and it is a very growing field, both in research, but also now we have full-scale applications that demonstrate that some of these standards, even for some specific pollutant groups, can be reached, even when we use only natural processes.
May I have a
Professor?
Okay.
I think we have a question that is addressed to Valentina Bastino, which must go first because she will have to leave the webinar in 10 minutes. So I would like to ask Ms. Bastino, and then Mr. Bocas Martin, you can give us your comment in a bit. Ms. Bastino, what developments do you expect in policy regarding water treatment and reuse in the next 10 years? And can we expect the Commission to subsidize and aid industry in this regard?
Yes, hello. I have to apologize. I actually sent a message to the whole panelists rather than just to whoever was asking me whether I could stay an extra 10 minutes after the time. So if you want, I can reply now, or you can put me back to the original place. It's as you wish. And apologize. Zoom is not a technology that I've been using so much in the last year.
That's not an issue. So Professor
I can-
Pocas Martin, can you please add your remarks?
Sorry about that.
Thanks very much. Two excellent interventions before, and I kept the issue of mental barriers, because there are no technological barriers. We actually are reusing water a lot, and it's safer to actually reuse water under completely controlled situation than under partially uncontrolled situation. So mental barriers are to be demolished, as many other barriers have been demolished. We are using masks now. We didn't think that was possible before. So if it makes sense, if there is technology, if it's affordable, why not doing it? Of course, reuse means organization. You don't simply reuse. The countries who have implemented projects for reuse, I mean, they are sophisticated projects. You cannot do reuse. Reuse doesn't come on its own. And there is another point which I think it's important. There are some questions about developing countries here. Water is a political issue, as I mentioned before, and we have the politician here, the Commission, has the power to change things. But in practice, if we know that 80% of people live in low income countries, they live under economic restrictions, it's very difficult, not technical, but economically, to provide free access, unlimited access for all. As human beings, we deserve it. But even so, in such places, it's common to have more than 50% water loss. And on the other hand, water supply is difficult, wastewater is much more difficult. It's not realistic to think about water-driven sewerage systems in most suburbs of African or Asian or South American cities. It just won't happen. I think dry toilets will be part of the solution. It will be much easier to reuse, to recycle water if we split the urine and the feces components, and it will be relatively easy to join these 2 points together, and with the same type of solution, we can have solutions for low-income countries and also solutions to very sophisticated places where pollution must be zero. So technology is here. The regulations are not, because we don't have enough regulations to actually reuse recycled water. And in the end, there will be the problem of mental barriers, but mental barriers, I mean, as I mentioned before, Cristiano Ronaldo and Madonna will solve it soon, quickly.
Thank you, Professor Pocas Martin. So perhaps Ms. Bastino would like to go now with the developments that we can expect over the next 10 years regarding policy and water treatment.
Yes, thank you. Well, there are a couple of initiatives that the Commission is actually currently already working upon, which have a very important bearing on wastewater and wastewater treatment and the potential use in industrial applications. The first one that I would like to mention is the ongoing review of the Urban Wastewater Treatment Directive. This is a directive which has been in force for decades. It's a very old one, and the colleagues in DG Environment are very busy trying to modernize it and make it more fit for the current world and the current available technologies. And indeed, in a situation where the climate change consequences are becoming more apparent, the concept of a wastewater treatment plant as a source of not only treated wastewater, but also reclaimed water or nutrients or other components like sludge, so energy, are indeed high on the agenda, also in the context of the Circular Economy Action Plan, which I have previously mentioned. So this is one of the ongoing processes on which also you could get engaged. There's ongoing public consultations on the topic, and the Commission is really trying to involve all possible stakeholders. I'm sure that the colleagues from water utilities and European associations of water utilities are well aware of this already. Another important policy development that you should expect in the next few years is, again, the ongoing revision of the Industrial Emissions Directive. Now, the Industrial Emissions Directive have just been, well, its fitness for purpose has been recently evaluated, and now it's the stage where colleagues in DG Environment are looking at ways of improving it and making it more effective. One of the results of the analysis was that while the directive has been fairly effective in the sort of end of pipe emissions, it has been slightly less effective when it comes to the efficient use of resources in terms of input to industrial processes. And one aspect indeed that this revision is looking at is how to look at issues related to water efficiency, including water reuse. So this is also another ongoing development and imminent results. I mean, in the next year or two, this aspect will be more and more examined and developed by the European Commission. As I mentioned earlier, the water reuse regulation also commits the Commission into looking into further uses. The time frame there is a little longer, in the sense that the commitment is that when the time comes to evaluate how the regulation has worked in 2028,
No.
that yes.
Can I just say to put some closing remarks, please, because we have
Sure.
some questions.
Okay, so just to conclude, in the evaluation of the water reuse regulation will be done in 2028, and there we should be in a position to also present potential new developments in the sphere. That is not to say that we will not be working on it in the meantime for the promotion of water reuse in further fields. Thank you.
Thank you so much for that, Ms. Bastino, and I apologize. However, we have a couple of questions from our audience, so we believe that we would like to tackle them. So in this case, I would like to give the floor over to Nadia Yang, who will be moderating the Q&A session. Over to you, Nadia.
Yes, thanks a lot for all the input. And we've indeed collected a lot of questions, and thank you all for staying a bit longer with us as well. To choose the most, to combine and summarize question areas, we have noticed that a lot of speakers here have been talking about freshwater prices, that they have been too low to incentivize companies and stakeholders to invest in water reuse. This is also a question from our audience. So, Ms. Bastino, you have talked about policies that are on the loop. I think a lot of people are wondering what is the Commission's opinion on freshwater policies and prices, and do you believe that a common methodology in water costing coming from an EU directive could be of a major assistance? Is that on the loop right now? Yes, this would be very interesting.
Hi, thank you for the question. I'm afraid that I am not an expert on the subject. It would be more other colleagues that are dealing with this aspect, so I will not venture into very specific answers. I just would like to recall that the Water Framework Directive does have provisions about appropriate pricing for water services, but I'm afraid I am not qualified to give precise answers. I know that there are also provisions in the treaty concerned with water, and we always have to take into consideration what we call subsidiarity issues. Therefore, there are certain level of decision making which are better addressed at the national level. But with that, I really would refrain from going any further. I can certainly inquire, and you might want to take contact bilaterally, and I could try to put you in touch with the colleagues that would be better placed to reply to your question.
Thank you very much. Going on with questions regarding regulations to Ms. Pizza. Someone asked us, what do you think would motivate companies more to prioritize a sustainable water reuse cycle? Is it more financial aid or regulations and law? And the focus should especially be for developing countries where water is very cheap.
Yeah, it will be probably a mix of the both, because you always need economical finances and even law. So in developing countries where I think the cost of water is still very, very cheap, the need is probably to make incentivization for such industries in putting in place technologies for recycling and reusing water, but we need also a decision at policy level, of course, always. It is a mix of the two.
Thank you very much. And sorry for summarizing the questions in a brief way, but closing this block of policies, we also had quite a few questions regarding the Kalundborg symbiosis. And we also heard that many people were impressed by its system. So the question was, how was the symbiosis collaborative system first designed? Who suggested it? And how did you manage to convince and include all the different sectors? To Mr. Müller.
Okay, in fact, it started about 40 years ago when the first industries was put in Kalundborg. And Kalundborg has the biggest concentration of industries outside Copenhagen. And the fact was that the directors from the companies was living in Kalundborg, and they met in the shops, and they started to drink coffee together and discussed how could we improve this? We need some water. Do you need water? And then they started to cooperate. In fact, so and then during the years, more and more streams has put on. It's been more and more sophisticated. We are looking into different types of materials and so on. So also, for instance, what can the utility do? We have a goal on the utility should be energy producing and CO2 neutral. We have been energy producing by using hot wastewater for the last 3 years. It is all about talking and drink coffee.
That would maybe be the solution for a lot of other places.
Yes, I think so.
So, and maybe to all panelists, either from the policy side or from the side, because we've heard about Israel or other Middle East countries or African countries that have been very advanced. So this is an example of a solution that could be uptaken for other places. Should there perhaps be standards that specific regions should also adopt or be more incentivized to adopt those kind of symbiosis solutions, and how can they really be incentivized to do this? What tools do they need? Okay, asking it more specifically, For example, to Ms. Bastino, if you said that you are very impressed by the system, what holds other places in Europe, for example, back, and how does the Commission tries to support them in this regard?
Can you? Yes, I think
Yes.
I'm on. I think that at this stage I should perhaps mention the available European funding. I think my commissioner mentioned in his speech that the EU is very keen on innovation and on technology, and it is trying to support the development of innovative systems, especially now with the circular economy action plans. There are funding streams that could be used to the purpose of developing innovative systems, and I think that something like this industrial symbiosis would be certainly something eligible. And also, in more recently, the member states are currently discussing what we call the recovery plans. In light of the COVID-19 pandemic, there has been in the last rounds of negotiations about the European budget, there has been a substantial amount of money being made available to help the member states and the economy to recover. And this recovery should be in line with the circular economy and the Green Deal priority of the Commission, which is about environment and about digitalization, amongst others. So I see there scope for these funding streams to go into this direction. Of course, deadlines are extremely tight. We have already heard back from some players that they might not be ready in time to tap that kind of money, but that does not stop the more ongoing funding streams, such as the regional development funding streams or the research funding streams, which are always looking at these innovative solutions. So this is something that could be looked at to bring that model to other places in Europe.
Thank you very much. Closing this section, we also received a few questions regarding nature-based solutions, so to Professor Stefanakis, and they were asking whether you are doing research on grey water treatment with natural methods as well. Do you think that treatment of grey water could be done locally at the premises of each affluent producer in order to relieve the burden of centralized facilities which are supposed to treat more polluted black water?
Yes, that is actually the approach. So it's not something new. It's called the centralized approach. So the idea is exactly that we are using mostly natural treatment technologies to relieve the burden for centralized facilities. So which means we can have smaller number of centralized facilities and also smaller in terms of capacity for the centralized facilities, which also gives the advantage that, as it was mentioned, in this case with the decentralized wastewater management, we have the treated effluent closer to the areas where we can reuse it. For example, in outside the cities, let's say. Allow me also to add something about generally the MENA, North Africa, Middle East region, because it was mentioned. I think that this region is even easier to apply the circular economy principles, exactly because it is a more, let's say, more virgin region, and there is not this extensive and established infrastructure that exists in Europe. So it is more easily to go and have some more radical and from grassroots, from the roots interventions there. While in Europe, although we have the resources, but sometimes it is not so easy within the established organization, within the established way we are doing work to change things. So in terms of these regions, I think there is a lot of opportunities generally for circular economy and of course for water reuse, and particularly for water and wastewater treatment and effluent reuse. This is where again, I will talk about nature solutions, nature-based solutions, maybe are more appropriate. I've had several experiences where some really high-tech, advanced, fantastic solutions were implemented in low-income regions. And guess what? After this was built within the project, the program, fantastic, they didn't have electricity to run the blowers or the whole systems 24 hours, or they didn't have the money to pay for the electricity. So it is also a matter of context. It doesn't mean that the most advanced technical solution applies to all contexts everywhere in Europe and in Africa. I hope I covered a few answers.
No, thanks a lot. And yes, indeed, you have answered a lot of questions at the same time. So we had a question to all our panelists, maybe especially Professor Pukas Martin can answer this. It was asked that whether there is a possibility that we can harness stormwater collected in our municipal stormwater networks, that we can augment to reclaimed water networks for optimization of water resource management. Of course, with considering economies of scale, environmental aspects, regional regulations, etc.
Well, thanks for the question. Yes, of course, reusing all the water makes sense. And of course, reusing stormwater makes a lot of sense. Of course, the problem is that storage is very expensive and it's not practical to store water from winter to summer in many countries. Basically, I think economy is the answer. So solutions are only sustainable and they will be followed if they make economic sense. Otherwise, there will be pilot schemes or whatever. And scarcity means that water is should be valued higher. When water is valued higher, the economic will solve part of the problems. Of course, we have differences in the world. We have differences in Europe. It's not easy to export or to transfer solutions from the wet Northern Europe to the drier Southern Europe or to Australia or middle of Africa. But water is getting and will get scarcer. And as it will get scarcer, people will have to be prepared to pay a little bit more for it. And industries, for instance, in the end, they compete with each other, and the ones that are more environmentally sustainable are the ones that will be more economically sustainable as well. It will take time. Regulations will have to be perfected, of course, but technology is there. It's affordable. But fresh water is still too cheap.
Yes, thanks a lot. In light of the time, one closing question to everybody so that you answer in 1 or 2 sentences, please. So how do you view the relationship between academia, policy, and industry in regard to water reuse in the circular economy? Please, your final thoughts. So, Ms. Pisa, you can go first.
I really didn't get the question. Could you repeat?
Oh, the question. We wanted to listen to your final remarks, but especially in relation to what you think about the current relationships between the industry, academia, and politics on this matter, whether they're collaborating or working against each other.
No, it is fundamental, and there are a lot of European projects on this topic that are seeing the collaboration among industry, water operation, and academia. And of course, we always need the point of view of university and technological research institutes. And what I have to add also to the last remarks from Professor Pocas Martin is also that in water reuse policies, we have always to consider one thing. We have a lot of standards in different European countries about water reuse, but we have no standards at all about the quality of the water we use normally for irrigation. So apart from the cost of natural freshwater resources, we have also to consider that the possibility to put in place water reuse schemes, also with the support of academic entities that can help the industries and water operator and better set their process, can be used also to implement the quality of such water with respect to natural sources that are in many cases really impacted by uncontrolled discharge of wastewater and other kind of problems.
Thanks a lot. Does anybody else want to put in their final remarks to this point? Yes, Mr. Müller.
I think that water
Thank
is a
you.
political issue in the end.
So,
And if
should I comment or?
Sorry.
Sorry, Mr. Müller was first.
Okay, thank you. But it was just to mention that also, as Pocahontas said, it's estimated that the total global water use with business as usual will approach and the average economic growth will raise from 4,500 billion cubic meters to 6,900. That is more than 40% over the known accessible freshwater. And that means that we simply have to work together. And there are three possibilities to solve this. It's a new water administration, it's water saving and water efficiency, and it's new technology and innovation. And if we don't cooperate, academia, industries, utilities on that topic, we can't win it.
Thanks a lot. Professor Pocas Martins, go ahead, please.
Well, I couldn't agree more. Basically, as the great issues are, water is a political issue. So, and it's also a very complex issue. It requires organizations. And to actually make things work, you need a strong organization. And the best examples in the world where reuse is actually performed, there are strong political decisions behind, there are strong institutions behind, and of course, the collaboration between between the industries, between the farmers and the academia is absolutely crucial. Of course, we need good laws, we need laws at the right time, we need the right regulations to make things happen. But institutions putting people together, putting different areas working together is difficult, and the politicians are the best people to actually put those in operation at a larger scale.
Thanks a lot. If there are no more final remarks, then I would hand over to Janice to close this webinar.
There doesn't seem to be any more closing remarks. I think with all that being said, we have now reached the end of our webinar. I would like to thank our panelists for being here with us today and sharing with us some great insights and value about water reuse and in a circular economy, and how it currently stands and its future. I would also like to thank the audience for staying the extra time with us to continue our brilliant discussion. So please do stay tuned on our social media channels, where we will be posting the recording of our webinar. And also, Stay tuned for the Engineering Future webinar, which will be organized by the WFEO-YEFL committee. So with that being said, I would like to say good afternoon to everyone. And once again, thank you for being here with us today.
Thank you very much.
Thank you, everyone.
Bye-bye.
Thank
Bye-bye.
you.
Take care.
Thank you for staying longer.
Thank you.
all.
Thank you.